Bismillah ar-Rahman ar-Rahim. Okay, let's look at this problem. This is OCW 26. So this is OCW 26. Okay, in order to raise the lamp, you have a lamp post from the position shown. Force is applied to the cable. This force is 4,400 Newton. Determine the moment produced by F, by this force, 4,400 Newton, at point A. So this is the point that we need to find the moment at. We have X, this is 3 meters, and we have the angle 68 degrees. Okay, so let's look at this problem from one side. Let's see. Okay, let's draw it. This is point A. This is point A, and this is point C. Point A, you can see that there is a tilt, a little bit tilt. And to point B, and this is point B. A little bit of tilt. Okay, this is B, and this is C, and this is A. This is 4,400 Newton. 6 meters here, the distance between A and B, and 3 meters is here between A and C. Look at this angle. The whole thing from here to here, you know, it's a straight line. The whole thing is 180. So you can subtract 180 from 68. Let's just do it, calculator. So 180 minus 68, and that is, this is now 112 degrees. Okay, there is an angle here that I don't know it. Let's make it phi. I don't know it. And we have the distances. You could apply the first law. We have here 6 meters distance from A to B. We have 3 meters distance from C to A. Let's find the length of this cable, C to B, using the law of cosines. So let's apply the law of cosines. To find out the distance from C to B. Okay, so CB, this is it's needed, is equal to the distance here square plus the distance from C to A square minus, remember from the definition of the law of cosine, 2 times 6 times 3, okay, 2 times 6 times 3, and then cosine 112. Okay, so cosine 112 times 3 times 6 times 2, and this is, then at the end it's a minus, so it's going to be plus 36 plus 9 plus 13.48. This is plus 9 plus 36 under the square root. This is CB squared, so CB 7.65. That is meters. So we found that we found the distance from C to B. Now you apply the law of sines to find out this angle, phi. law of sines. So we apply the law of sines. Here we divide BC over this angle. You can see that this is the angle in front of the BC, sine 112 equal 3 over sine phi. So now BC we have it. BC we have it, and that is 7.65. So 7.65 over sine 112 is equal 3 sine phi. Let's look at 3 times sine 112 over 7.65, the inverse sign for that, and that is phi is equal to 21.3 degrees. So we got this angle. Now it is it will be, this is 21.3 degrees. So now we could find out the moment at A. So how are you going to find the moment at A? Let's just do it with a different color. This force would be like this on the cable. Let's see. One force this way. Ooh, let's do it with the red. One cable like one like that, and that's gonna be 4,400 cosine phi, and one force gonna be perpendicular. That's gonna be 4,400 sine phi. Okay, you can see that at the moment A, this force 4,400 cosine phi, it has no moment because it is at the same line of action of A. The only one that has a factor is 4,400 sine phi. So the moment at A, it is 4,400 sine phi, which is 21.3 times the distance perpendicular, which is 6 meters, times 6, and that would give you 21.3 sine of sine 21.3 sine times 4,400 times 6, and this would give you 9,590, and that is Newton. It is, yes, meter and Newton. Okay, so it's Newton meter, and we could make it divide by 1,000 to make it moment A 9.59 kilonewton meter. And you could see that this force will produce a moment around point A counterclockwise. So this is going to be counterclockwise. Thank you.